All right, welcome. This is a long series, but it's sort of important. We are still looking at different kinds of components. And this session's component is the transistor. You've seen transistor, we've used it earlier to turn on and off an LED and a buzzer, but here's a bit of a closer look at it. Basically, a transistor can be one of two things. It can be a switch where you have a very low power or low voltage or low current input that is able to control a much larger load, for example. So in that sense, it acts as an electronic relay of sorts or a switch of sorts, which can be controlled via a logic circuit such as an Arduino Nano. And the other application for transistors is that they can act as actual amplifiers, where you can vary the signal that goes on the input and it increases the amplitude of that signal on the output. So that's most commonly used in RF circuits, in audio amplifiers and so on. So these are the two basic, let's say, the main applications for transistors. And again, transistors come in all sorts of shapes, types, varieties, sizes, and so on. It's really a big, really big field. But the two main categories of transistors are NPN and PNP, and this is basically referring to the structure, the internal structure of how the transistor is fabricated. We also have different types of transistors, like the one that you see in front of you, or the normal one that we refer to, are known as bijunction transistors, or BJTs, because they have two junctions. You have an NP junction and then a PN junction, which forms the NPN, or the other way around, a PN junction and an NP junction that forms a PNP. So those are BJT or bijunction transistors. But then you also have other ones like a field effect transistor, which works in a slightly different way, where you have a voltage that is applied to the input, and that's able to again control the current that flows through the output. So again, FETs come in all kinds of different types, as P channel, N channel, and so on. And then there are further variations on FETs, for example, MOSFETs, metal oxide semiconductor field effect transistors. That's a mouthful, but it refers to the technology that's used to make those devices. And MOSFETs can handle large powers, large currents, and so on. They can switch big loads and stuff like that. So again, a really large field. Let's look at quickly some of the real world places where you'll find transistors. So again, this is our arcade circuit, and you'll notice that we have the same NPN transistor BC547 installed over here at the location Q1. That's used to drive the buzzer, and it's acting as a sort of a amplifier, because the output from the Arduino Nano might not be enough to directly drive a buzzer. Here's another module, which is a haptic motor. It's basically a vibration motor, and it has 3 pins that you can connect to something like an Arduino Nano. It has a supply pin, a ground pin, and a signal pin. Now, the signal pin goes to a transistor. There's a little tiny device here that you can see here. So this is a surface mount or an SMD transistor. It's electrically or electronically the same as this one, except this one is through hole and larger, whereas this one is really tiny. And otherwise functionally exactly the same, different size and shape, probably different electrical characteristics to some extent. So that's another kind of transistor. Here's another circuit where we have this transistor, which is much larger. You can see this large metal piece connected to it, because that allows it to dissipate or transmit heat away that is generated because it's passing a lot of current through the device. Sometimes if that is a lot, we will connect a heat sink to it, and if that's not enough, we will also add some fans to cool it and so on. So it depends on the amount of power that is passing through the device but I'm not sure if this is a regular NPN or PNP, or it could even be a MOSFET. Markings are not clear, but yeah, so that's a transistor. I don't see any other transistors on this device or on this circuit over here. But if you take your ATmega, it literally consists of thousands of transistors internally. So every function within the ATmega is basically consists of a sequence or a series of different transistors connected in a certain fashion. So that's pretty interesting. Transistors are sort of everywhere in electronics. Every integrated circuit you see is practically made out of different kinds of transistors and so on. So pretty interesting and amazing devices that are used in electronics. So on the screen I have this typical BC547 transistor, and you can notice that the number TO92, that refers to the size and the dimensions of the package that is created in. So this package is a TO92 package. This one, the big transistor that you saw, this is the TO220 package, right? And this one that you saw in this module, this one is a SOT23 package, surface outline package, surface mount package of sorts. So we have different kinds of packaging. Transistors have three legs: a collector, base, and an emitter. If it's an FET, it would have a drain, a source, and a gate. But otherwise, even FETs have three legs or 3 pins. And this is the electrical schematic of how we want to draw it when we're drawing a diagram. It will have the collector. The emitter is indicated by an arrow, and if the arrow is pointing outwards like so, then that's an NPN transistor. If the arrow is pointing inwards towards the base, it's a PNP transistor. That's how you identify the NPN and PNP transistors. And here's really how it works. Like I said, it's a switch. You have a small amount of current that flows from base to the emitter, and then any load that you connect between a power supply and the collector, a large current will flow from that power supply's positive terminal through the load, through this collector, and then to ground where the emitter is connected. So if you have a small current going between base and emitter, you can have a large current that allows you to control a large load connected to the transistor, and that current flows from the collector to the emitter. So that's a really very short and quick tour of transistors. If you find it interesting, feel free to Google it up. You'll find tons and tons of information about what a transistor is, what are the different types, shapes, sizes, varieties, and so on. So keep learning.